Module 2, Unit 3, Creating a Positive Classroom Environment. Creating a positive classroom environment is fundamental to effective science education, particularly when using inquiry-based instruction. A positive environment is one where the physical and social emotional needs of students are addressed and where learning is rigorous, engaging, and underpinned by trust. Both teachers and students must believe that learning is possible for everyone. Designing such an environment promotes active inquiry learning and ensures that students are motivated and focused on their educational journey. To achieve this, teachers need to plan meticulously for both the physical and social-emotional aspects of the classroom. The physical environment should be organized in a way that supports learning and ensures safety. This includes arranging furniture to facilitate easy movement and collaboration among students, ensuring that materials are readily accessible, and creating a space that is inviting and conducive to exploration. Safety procedures must be clearly defined and understood by all students to prevent accidents and promote a sense of security. The social-emotional environment is equally important. A classroom that fosters positive relationships and mutual respect will encourage students to participate actively and take risks in their learning. Teachers can promote this by modeling respectful behavior, setting clear expectations for conduct, and providing consistent support and encouragement. This helps create a community of learners where students feel valued and are willing to engage deeply with the content and help each other learn through discussions and collaboration. Inquiry-based instruction thrives in a positive classroom environment. This approach requires students to engage actively in the learning process, asking questions, conducting investigations, and developing explanations based on evidence. For this to be effective, students need to be coached on how to work collaboratively in groups, assign cooperative roles, constructively talk through problems, and design procedures that lead to conceptual understanding. Establishing these practices from the beginning of the school year is crucial as it sets the tone for the entire learning experience and ensures that students are prepared to engage fully in inquiry-based activities. Learning centers play a significant role in promoting inquiry-based learning, especially in the lower grades. These centers provide opportunities for students to engage in hands-on investigations, develop a deeper understanding of specific science concepts, and work independently or in small groups. Learning centers can motivate, guide, and support student learning, allowing teachers to meet individual needs and provide self-directed learning opportunities. Maintaining a safe and supportive learning environment requires careful planning and consideration of various factors. Teachers should take into account patterns of student movement, which influences how students interact with the physical space and with each other, impacting the overall learning experience. Ensuring that the classroom is organized and managed effectively helps prevent accidents and promotes a sense of order and safety. The main purpose of classroom management is to control student behavior and ensure student safety. When misbehavior prevents the learning of others or is potentially dangerous, it is considered disruptive and must be addressed promptly to maintain a safe and conducive learning environment. Mandatory attendance at after-school conferences adds to teachers' already heavy workloads, extending their work hours and increasing burnout. Additionally, these conferences often involve stressful interactions with parents, further contributing to job dissatisfaction and prompting some teachers to leave the profession. During classroom observations, principals often evaluate the level of on-task behavior. If a novice teacher's evaluation indicates a lot of off-task behavior, it likely means that many children were not paying attention, which can significantly impact the effectiveness of instruction. Cooperative and collaborative learning structures can help address this issue by promoting peer interaction and discourse, assigning roles and responsibilities to ensure effective participation, and fostering a sense of shared responsibility for learning outcomes. This structure can also allow teachers to stretch limited hands-on materials. Classroom safety is paramount, and teachers need to be familiar with fire regulations, evacuation plans, and the location of firefighting equipment. Emergency contact numbers should be posted in classrooms, and safety contracts signed by students and parents are necessary even in primary grades, as elementary investigations can involve risks. Teachers must ensure that the room's size and arrangement support safety, preventing crowding and facilitating safe movement. Teaching procedures is critical to maintaining a safe classroom environment where students know what is expected of their behavior. This includes using goggles when working with powders and liquids, not allowing eating in the classroom to prevent chemical contamination, and using plastic or unbreakable laboratory equipment. If glass gets broken, it should be cleaned up and disposed of in a container specifically for that purpose. Washing your hands well after an investigation is a very important safety rule that should always be followed by students. When dealing with students who have emotional and behavioral disorders, teachers should provide a safe and supportive learning environment for all students. The goal is to ensure that all students can learn in a safe and supportive environment. Unit 4. Learning science with understanding. Understanding science involves more than just memorizing facts. It requires the ability to explain, interpret, apply, and adapt knowledge. This unit explores how students can be guided to deeper understandings of science concepts using various approaches and how their alternative conceptions can be changed through a conceptual change model. To grasp science concepts fully, students need to move beyond rote memorization to a stage where they can use their knowledge creatively and flexibly. The revised Bloom levels describe this cognitive demand as the ability to apply knowledge, which involves predicting, implementing, modeling, or demonstrating scientific principles. For example, a second-grade class investigating how water shapes land using a stream table engages in a modeling activity, illustrating the practical application of scientific ideas. In another instance, a fourth-grade class studying the stretch of a rubber band when weights are added conducts an experimental investigation. This hands-on approach helps students understand scientific concepts through direct experimentation and observation. Some topics, such as how to safely handle chemicals during an investigation, might be better taught using direct instruction approaches like Hunter's lesson design, emphasizing safety protocols over inquiry-based learning. When students encounter a scientific phenomenon with surprising or unusual outcomes, known as a discrepant event, they are encouraged to rethink their existing beliefs and construct new understanding. This is part of the process of conceptual change, where learners replace their misconceptions with scientifically accurate concepts. For example, evidence of a learner's conceptual understanding includes their ability to construct mental or physical models, use concepts in new contexts, and describe ideas in their own words, as well as finding metaphors or analogies. Constructing new knowledge is an active process where learners use prior knowledge to organize incoming information and integrate it to expand their knowledge base. This process is facilitated by teachers who provide appropriate scaffolding, helping students bridge the gap between their current understanding and the level they can achieve with assistance, known as the zone of proximal development. Current learning theories support the idea that students learn science by actively engaging in scientific practices. Children enter school with substantial knowledge of the natural world, which can be expanded by teachers designing activities to enhance students' reasoning abilities, though it is not solely age that determines a student's capacity to learn science, but rather their prior learning opportunities. Researchers agree that what children are capable of learning about science largely depends on their prior opportunities to learn. Effective science teaching requires awareness of students' preconceptions and the ability to address and resolve conflicts between these preconceptions and scientific concepts. This process involves becoming aware of students' ideas, confronting and challenging these ideas, and guiding students to extend and apply new concepts in various contexts. Understanding a scientific idea involves more than recalling definitions. It includes applying new knowledge to solve problems, using knowledge in different contexts, and creating models to represent scientific phenomena. For instance, students might demonstrate their understanding by constructing models or finding analogies for scientific concepts, which shows deeper comprehension beyond mere memorization. The social constructivist model of learning emphasizes that learners must actively engage with new information, select and organize it meaningfully, and integrate it with their existing knowledge to construct new understanding. Alternative conceptions, or misconceptions, are children's ideas that are not congruent with accepted scientific views, are easy to change with appropriate instruction, and are no cause for concern. These are common in students and must be addressed through targeted instruction that helps students become dissatisfied with their misconceptions and adopt scientifically accurate views. For conceptual change to occur, teachers must present scientific conceptions, recognize students' misconceptions, and help students become dissatisfied with these misconceptions. This involves enabling students to apply and integrate new concepts into their thinking, moving beyond simple memorization to a deeper understanding of scientific principles. In summary, learning science with understanding involves a shift from memorizing facts to engaging in processes that allow students to explain, interpret, and apply scientific knowledge. Through hands-on investigations, direct instruction where appropriate, and addressing misconceptions, students can develop a robust and flexible understanding of science concepts that they can apply in various contexts. This comprehensive approach to science education ensures that students not only know scientific facts, but also understand and can use them in meaningful ways.